Welcome back to Past Light Insight Academy. Today we're having pH and pOH under pH scale. What is pH? pH is potential of hydrogen. And anything we are measuring about hydrogen is what? Acid. Acid gives us what? Hydrogen ions or hydrozonium ions. While pOH is for base. Potential of hydroxide, that is for base. Let's go to pH scale now. pH scale ranging from 0 to 14. From 1 to 6, you can see the arrow increase in acidity. The meaning of this is that, as you can see it here now, 6 is less than 5, 5 is less than 4, 4 is less than 3, 3 is less than 2, 2 is less than 1 in terms of acidity. Meaning they can ask which of these has the strongest acidity. The strongest acidity. Option A 1.5, option B 6.5, option C 2.5, and D 7.5. So if you look at it now, the strongest among them, I told you 2 is less than 1. So 3 is less than 2. 4 is less than 3. 5 is less than 4. 6 is less than 5. So the strongest is 1.5. So strongest acid, 1 is greater than 2. 2 is greater than 3. 3 is greater than 4 in terms of acidity. But in alkalinity now, 8, 9, 10, 11 is the ranges. So 9 is greater than 10, 9 is greater than 8, 10 is greater than 9, and so on and so forth. So that is the pH scale. So let's go to potential of hydrogen formula. In pH, the definition is the negative of hydrogen or in concentration of log 10. So that is the definition. The negative of hydrogen in what? Concentrations of the log 10. So that is the formula for hydrogen. So you can also have that too for your pH is equals to minus log 10, the same thing with H3O plus hydrozonium. This too is acid. Acid produced. So you can also have something like this. If you want to simplify this, pH is equals to log 10 H plus loss of logarithm. So this minus is going to the top here. So minus is one of the laws of logarithm. So when you have something like this, pH is equals to anything that is minus, can also bring it down like this, 1 over log 10 H plus. So we get that because of the minus here. So anyway, you see my loss of indices, A raised to power minus 1, it means 1 over A. A raised to power minus 2, it means 1 over A raised to power 2. So because of this minus, just bring everything down. So you can be using these equations to look for your pH. Likewise, the same way, just solve that for your pH of H3O plus, the same way. So let's go to the base. pOH for the base now. So our potential of hydroxide is having minus log 10. This one is OH, that is OH minus. OH minus. Then we have something like this. pOH now, minus log 10 OH minus for the base. So the same way, take this minus to the top here, that is law of logarithm, log 10 OH minus. This minus going to be minus here. Then the same way, that is having minus is 1 over the number, 1 over log 10 OH minus. So this is what we are having there for pOH. So this is for acid, this one is acid, while this one is for base. Relationship between pH and pOH now. pH plus pOH. Please note this, very, very important. On the scale, I told that it's getting from 0 to 14. So the measure of the acid and the measure of the base, when you add them together, they will give you 14. Or the ranges start from 0 and end at 14. So pH and pH is 14. What is your pH? From there, we have what? Minus, can use minus log 10 H plus. Then what is your pH? Can use minus log 10 OH minus. All is equals to 14. So this is for pH, this is for this. What is common between them? Minus log 10 is common. It's common. So this place is H plus times OH minus. This is loss of logarithm. Why is this something like this? Log 1 log A times B. It means log A plus log B in a separate form. This is separate, but you can bring them together. Picking one log, then you times them, is equals to 14. So as you can see it now, take this minus to the other side, log 10 H plus dot OH minus is equal to this minus goes to the other is minus 14. At the end of the day, this log 10 is going to the other side. You want to eliminate the logarithm. This side is having logarithm, this side is not having. So this 10 is going to the other side. So you are going to have H plus dot OH minus. This 10 is going there, so that will be 10 raised to power minus 14. We call this elimination of logarithm. This 10 is not going to the other side. So it raises the power up. So this is one of the formula you can be using to solve any questions on pH and pOH. Equation 3 for today. This is 1, this is 2, and this is 3 for today. Now look at the first example on the board. Find the pH of 0.1 mole per dm cube. This is the concentrations. Hydrochloric acid. You just start. Solution. The concentration that was given to you is for hydrochloric acid. So let's go. HCl means hydrochloric acid. It's an acid. So split them. We are having H plus Cl minus. So it's balanced. H is 1, hydrochloric is balanced. So my H plus, the concentration of H plus now from here, from this expression, this is 0.1 mole per dm cube. That is what we have here. And that is what they give to us. So find the pOH. You are looking for pOH. But this is pH. You first look for pH. pH. What is pH? That is the formula is minus log 10. You can use that. So H plus, this is formula that is in your notes. So this is formula for pH. First get your pH. So it's equal to minus log 10. H plus, what is H plus? 0.1 is 0.1. So is equals to minus log 10. Without the calculator, 0.1 is 10 raised to power minus 1. That is 0.1. You can use your calculator to get that. So take this minus 1 to the back. There's no minus. Minus 1 is coming, minus 1. Log 10, 10 is 1. So because it remains log 10, 10. Minus times minus, that is plus. This is 1. And log 10, 10, 2 is 1. When you see log 10, 10, log 5, 5, log 2, 2, they are 1. You can press your calculator log 10 to give you 1. So 1 times 1 is 1. So my pH is 1. And the question asks us to get pOH. You see 1 is part of the options. So let's go there. pH plus pOH is equals to 14. If my pH is 1, pH is 1 plus pOH is equals to 14. So my pH will be 14 minus 1. 14 minus 1, that is 13. So the final answer to this question is 13. Calculate the pH of 0.05 mole per dm cube solution of tetraoxosulfate 6. I told you, you are only after this acid here. The same thing hydrochloric acid, that is the first thing to do. Then that is H2SO4. Split this. You are going to have H plus SO4 2 minus. One should have plus, the other should have minus. Then hydrogen is 2, hydrogen is 1. Just put 2 here. It's balanced. So our H plus here, now you can see that is 2. 2H plus is equal to 2 of this. That is 2 is 0.005. At the end of the day, we have 0.01 mole per dm cube. So this is the concentration we are using. Then you can take it to 1 times 10 raised to power minus 1, 2 times 10 raised to power minus 2 mole per dm cube. So 1 times 10 raised to power minus 2 mole per dm cube. So let's go back to the formula for pH. pH is equal to minus log 10 open bracket H plus. That is our formula. So pH is equal to minus log 10. Why is the H plus? This is 1 times 10 raised to power minus 2. So you can bring this minus 2 to the back. So pH is equal to minus, this minus 2 is coming to the back. So that is minus 2. Then we only have log 10. 1 times 10 is still 10. That is 10. Then we can have pH is equal to minus times minus plus 2 times log 10, 10 is 1. 2 times 1 is 2. So your pH is 2. Thanks.